All right, so real quick then, a question that commonly comes up with projectiles is, obviously we should be able to get maximum trajectory at 45 degrees, maximum range, but what happens about the range if I go, for example, 25 meters per second at 30 degrees? Right? Is there another angle that's higher than 45 that will allow me to shoot that projectile the same distance? And in fact there is, if you, and I'll show in just a second, but if you change the angle above or below by an equal amount, the range of the projectile, if it starts on the ground, comes back to the ground, or starts at some initial height, coming back to that initial height, the distance that it travels in those two paired angles will actually be the same. So we're going to look at, in this case, 25 meters per second at 60 degrees above the horizontal on the ground, and compare that to 25 meters per second at 30 degrees and look at the ranges there. So I've already done the components of each of those. Right, the 25 at 60 has a y component of 21.65 y, 12.5x. Because 30 and 60 are acute angles that add to 90, we look at those being opposite. Cosine 30 times 25 is 21.65x for the lower trajectory and 12.5 meters per second y. So if we look at those velocities in the y direction, we can calculate the total time up. Double that would be the total time the projectile will be in the air in each case. So I get, 21.65 over 9.8 gives me time for that projectile to get to the top, which is 2.209 seconds. And I multiply that by 2 to go, obviously, up and back down. Gives me 4.42 seconds total. If I look at the lower trajectory, I'm going 12.5 meters per second divided by 9.8 gives me a time of 1.275 seconds to get to the top. I multiply that by 2 to get my 2.55 seconds for the total up and down flight. Now, during that entire time, in each of those cases, the projectile will be traveling with a horizontal velocity that's constant. So in the upper case at 60 degrees, I'm going at 4.42 seconds times 12.5 meters per second. And that gives me a range or a distance of 55.21 meters. If I look at the lower case, same thing, distance equals velocity times time, which is then 21.65 times that shorter time of 2.55, and I get calculated 55.25 meters as my range, right? Well, due to the fact that I had some rounding in there, I get a difference of 4 centimeters, but you can see how the velocity of the projectile, if I were to go at 40 degrees and 50 degrees, right, or 35 and 55, or 15 and 75, I would get that same range, one of the projectiles being lofted much higher for a longer time, and one of them being lofted, at a shorter arc, right? Not as high up, but still traveling the same distance. So a shorter time, but a greater velocity in the x direction. So that's just an example of, what other angles we might use to get the same result. And there might be various instances where you would want to, launch a projectile higher or lower depending on constraints in the environment around you. So that's just an example of that. I think there's a couple problems that discuss this topic on the projectile tutorial. It's in Word, posted on Edmodo. So I'll throw this up there and you'll have a look at that as well. So I just wanted to kind of touch base on that.